Writing net ionic equations for precipitation reactions. In this section, we're going to learn about writing net ionic equations for reactions which produce solid precipitates. There are a set of rules for writing net ionic equations. When you write an equation for the precipitation reaction that occurs, if one does occur, when solutions of sodium carbonate, Na2CO3, aqueous, means it's dissolved in water, and copper 2 chloride, aqueous, are mixed. Okay, so we take our sodium carbonate and we break, because it ionizes, because it is soluble based on the solubility rules that you learned, so it breaks apart into sodium ion and carbonate ion. You take your copper chloride, based on the solubility rules, it's aqueous, so it breaks apart into copper ion and chloride ion. Then, now you have all your ions free in an aqueous solution. So now, copper, which was with chloride, can pair up with carbonate, and that's exactly what happens. Is if a potential exists for a solid to form, it will. Copper and carbonate will form copper carbonate as a solid species, and that is referred to as a precipitate. Now, sodium chloride, sodium and chlorine don't do anything. They are just spectator ions. They stay in solution. So they are spectator ions. They stay in the solution. Okay, so the potentially insoluble products were sodium chloride and copper carbonate. Based on your rules, you found out that copper carbonate is an insoluble substance, so the reaction forms copper carbonate. So here we go. Make sure to write correct charge formulas for the new ionic compounds. Use the solubility rules to determine whether any of the potential new products are indeed insoluble. Sodium chloride is soluble. Sodium carbonate is insoluble. So since carbonate is insoluble, the reaction goes. So if all the potentially insoluble products are soluble, there will be no precipitate. Write no reaction next to the arrow. One of the potentially insoluble products is insoluble, so write its formula as the product of the reaction, using S to indicate it's a solid. So the copper carbonate that we had is the precipitate that forms. Okay, we write our other species back together with AQ because that's indicating that they're dissolved in solution, and our sodium chloride that forms will be AQ also because it's soluble in the reaction solution. Balance the equation. Remember to adjust only the coefficients, not the subscripts. So we need a 2 here because we had a 2 there. When we do that 2, it makes this chlorine have 2 and goes ahead, and now it's balanced. Okay, now what we want to do is we want to talk about writing chemical equation for reactions in solution. We're going to talk about just writing the important stuff. Okay, so just writing what's called a net ionic equation, just the equation that is doing the chemistry to make something new. So a molecular equation is like what we've been doing from here before this. Is an equation showing the complete neutral formulas for every compound in the reaction. So silver nitrate plus sodium chloride gives silver chloride, that's a solid, and sodium nitrate solution. Notice what we did here. We just swapped partners and said silver chloride and sodium nitrate. Silver chloride, based on the solubility rules, is a solid, so that is a reaction. Sodium nitrate is aqueous, so those will just be hanging out in solution as spectator ions. We write a complete ionic equation showing aqueous ionic compounds that normally dissociate in solution as they are actually present in the solution. So if we have silver nitrate, we break that apart into its component, silver 1 and nitrate. We have sodium chloride, we break it apart into its ions, sodium and chloride, because these are all in water, and when they dissolve, they exist as their ionic species interacting with water molecules. Now, our silver chloride is a solid, so we have to write it as a solid. Our sodium ion appears again on the right-hand side. It didn't change, and neither did nitrate. So, when writing complete ionic equations, separate only out the aqueous ionic components into their constituent ions. So notice everything that was AQ got separated into its constituent ions. Now notice that we have silver ion on this side. Whoops, I need to erase that. Except I don't know how, if that's okay. Let's stop the video for a second. Okay, so let's back to what we were doing. Okay, so silver ion, does it have, we're going to write what's called a net ionic equation. You see how nitrate ion exists on this side, and it exists in the same way on this side, so it gets canceled. Notice how sodium ion exists as sodium plus 1 on this side, and it also exists as sodium plus 1 on this side. Now, silver, on the other hand, exists as silver plus, but it exists in a compound over here, so we can't cancel it. Chloride exists as Cl minus, and it exists in a compound over here, so we can't cancel those. When writing complete, so what we have written here is a complete ionic equation. We take it and we're going to turn it into what's called a net ionic equation. So this is the complete ionic equation. Okay, so in the complete ionic equation, some of the ions in solution appear unchanged on both sides. These ions are called the spectator ions because they do not participate in the reaction. But the other ions participate in the reaction, and these are not spectators. But in here, nitrate, sodium are spectator ions. So to simplify the equation and to more clearly show what is happening, the spectator ions can be omitted. Equations such as this one, which show only the species that actually participate in the reaction, are called net ionic equations. Let's go back here for a second. So if we're going to cancel these out, then all that's left is silver plus aqueous chloride gives silver sulfide. And doesn't that make sense that that's really what's going on, because everything else is just hanging out in the same state it was to begin with. So this is called a net ionic equation, and you need to be able to write net ionic equations, and we'll do some more practice. So a molecular equation is a chemical equation showing the complete neutral forms for every compound. A complete ionic equation is a chemical equation showing all the species as they are actually present in solution, broken into their ions. And a net ionic equation is an equation showing only the species that actually participate in the reaction. Let's write an equation for the precipitation reaction, if any, that occurs when solutions of lead 2 acetate and sodium sulfate are mixed. So what we do is we write the formulas for the two compounds being mixed as reactants in a chemical equation. Now you should, by now, be able to If you have lead acetate, and I told you need to learn acetate, lead 2 acetate, you know that it's written like this. And sodium sulfate is written like this. Now what you do is you swap their partners. You're going to swap their partners to see if swapping their partners, once they get into solution, gives you the possibility of having any solid precipitate. Below the equation, write the formulas of the potentially insoluble products. So again, swapping the partners, it would be sodium acetate, and lead sulfate. Okay, these are obtained by combining the cation from one reactant with the anion from another. Make sure to adjust the subscript so all the formulas are charge neutral. Use the solubility rules to determine if any of the potentially insoluble products are indeed soluble. Now we know that sodium acetate, because it's got sodium in it, the rule says it's going to be aqueous. So let's write aqueous by it. That is aqueous. Okay? So Na2CO3 is soluble. Lead sulfate is insoluble. So let's write solid beside it. So we are going to have a reaction because we're forming this lead sulfate. So if all of the potential products are soluble, there'll be no precipitate. But in this reaction, we do have a precipitate. Since this reaction has an insoluble product, proceed to the next step. Okay, so if both of the potentially insoluble products are indeed insoluble, write their formulas as the products of the reaction, using S to indicate solid. Write any soluble products with AQ. So we use both of our reactants, and we wrote lead sulfate because lead went with sulfate, sodium went with acetate, and we have this solid. Now then you want to balance the equation. So to balance the equation, you have to look at it and decide that you need a 2 right here because you need 2 sodiums, because you have 2 sodiums and you need 2 acetates. Now we're going to write the net ionic equation. Oops. Okay, so we're going to write the net ionic equation, which is going to be, this is everything that's aqueous, AQ, is written out as its ions. So we've got lead, and in this case it's lead 2 plus. Okay, we've got acetate ion, which is C2H3 O2. Okay, and that's -1, but we've got 2 of those that come with the lead acetate. We've got sodium, 2 sodium plus 1s that come with the sodium sulfate. And we've got 2 sulfates, 1 sulfate, my bad, sulfate. Okay, now our products are going to be lead sulfate solid. We do not write this as separate ions. We write lead sulfate solid. Okay, plus, now this one is aqueous, so it gets broken into its 2 species. 2 sodium plus 2 acetate, C2H3O2 minus. Okay, so whatever occurs on this side and occurs in the same state on this side gets canceled. Lead 2 cannot be canceled because it does not occur as lead 2 on the product side. These 2 acetates, however, can be canceled because they occur the same on both sides. These two sodiums can be canceled because they occur the same on both sides. Sulfate cannot be canceled. So notice what we're left with. We're left with lead, 2 plus, aqueous, plus sulfate, 2 minus, gives 1 lead sulfate. We need our symbol solid. This needs to be AQ. Okay, so this is what's called the net ionic equation. Okay, this right here, this equation before we did all the canceling was the complete ionic. And why my pen is acting weird. Complete ionic equation. Okay, let's do another. Predicting and writing equations for precipitation reactions. Write both a molecular equation and a net ionic equation, if any, that occurs when solutions of potassium sulfate and strontium nitrate are mixed. Whoops. Okay, so potassium sulfate we need to know that potassium sulfate is K2SO4. Okay, we know that that's going to be aqueous because potassium compounds are aqueous. So when potassium sulfate and strontium nitrate, okay, strontium nitrate, so we need to know whether strontium, what's the formula for strontium nitrate? So take out your periodic table, look up strontium, decide what it is, what its charge is going to be. It's in the second column, so strontium is going to be a 2 plus and nitrate is 1 minus, so we need NO3. We need 2 of those. Okay, so now we want to decide if when these two things switch partners, is there a possibility of forming a soluble compound? So here we have potassium, the potential products are potassium nitrate, which we know will be soluble, okay, and the other potential product is strontium sulfate. Okay, and strontium sulfate, based on our solubility rules, sulfates will be a solid. Okay, so now let's write the net ionic. That's the complete equation. We haven't balanced it, so let's balance it. We got 2 nitrates here. We need to put a 2 there. That takes care of our potassiums, and we're all balanced. But now let's write everything that is aqueous. Everything that is aqueous. Oops, and I wrote this as aqueous. This is not aqueous. This is not solid, it's aqueous. Write everything that's aqueous as aqueous. So K plus, we've got 2 of those. Okay. Sulfate, we've got 2 minus of those. Okay, I mean the charge is 2 minus. We've got strontium, 2 plus. We've got 2 nitrates. Okay, then on the product side, we've got 2 potassiums. We've got 2 nitrates. Okay, and we've got one solid compound, which is strontium sulfate. And it's a solid. Okay, so that is our complete ionic equation. So that's our complete ionic equation. Now let's cancel what we can cancel. So potassium occurs over here, 2 potassiums, those cancel. Okay, sulfate occurs as an ion over here, but it's in a neutral compound solid here, so we can't cancel it. We can't cancel strontium. We can cancel these 2 nitrates. Okay, so our overall net ionic equation then is going to be SO4 2 minus plus strontium. I don't know why my pen's not wanting to write right. Strontium 2 plus gives strontium SO4 solid. And these really need to have AQ written here. Just having trouble with my pen writing. It's supposed to say AQ. So anyway, the answer is, that's the molecular answer, but the net ionic equation is strontium sulfate plus strontium ion gives strontium sulfate. Alright, let's write a balanced molecular equation, a complete ionic equation, and a net ionic equation for the reaction of sodium sulfate with cobalt. Oops. Let's get a different pen color. Let's use green. Okay, complete balanced equation for the reaction of sodium phosphate Na2PO4. Oop, and that's not going to be right because it's not Na2, it's Na3. So we make that a 3. PO4 is just 1. Okay, so we really don't need the parentheses. Let's delete that. Okay, so let's write that again. Na3PO4. Okay, and that's aqueous. All right, our second reactant is cobalt 2 chloride. So that's COCl2. Possible products are sodium chloride. That's when sodium switches partners here. And cobalt phosphate. Okay, cobalt 2 phosphate. So that would be CO3, because phosphate's P minus 3, PO4. We need 2 of those. Okay, so we have cobalt phosphate. If we look in our table of solubility rules, then we'll see that if you have phosphates, then phosphates are going to be insoluble unless they're with lithium, sodium, potassium, or ammonium. And they're not, it's with cobalt. So this is going to be a solid precipitate. Okay, this will be AQ because it's with chloride, and this will be AQ. So let's write our net ionic equation. We've got 3 sodiums plus a phosphate. Oh, and we didn't balance it, so we need to make sure we balance it because we've got 2 phosphates over here and 3 cobalts. So we need to put a 2 here. That gives us 6 sodiums, 2 phosphates, 3 cobalts. We need to put a 3 right here, which gives us 6 chlorines and 6 sodiums. So this needs to be a 6. So that means then that we have not 3 sodiums, but we have 6 sodiums over here. We have 2 phosphates. We have 3 cobalt 2s. We have 6 chlorides, yields 6 sodiums plus 6 chlorides plus 3 cobalts. Oh, my bad. We can't plus, well, it's going to be 3 cobalt phosphates. Write that as a solid. So all 3 of those get rid of that. So all 3 of those stay. Look at the problem. We've got 6 sodiums here. We've got 6 sodiums there. So those will cancel. We got 2 phosphates. I forgot it's charged. 3 minus. Okay, those do not cancel because they occur in a solid compound over here. 3 cobalts. Those do not cancel because they occur in a solid compound over here. 6 chlorides. Those do cancel. So now we just bring down and write what didn't cancel. 2 PO4s plus 3 cobalt 2 pluses yields 3 CO PO4 2 solid. Okay, so that is what's called the net ionic equation. Alright, so it's really important that you practice these problems. So I'm going to make sure that you practice this problem by choosing for your quiz this example problem, and I'm going to choose one of these in the back of the book. So you will have a quiz. This example problem and one of these blue problems from the back of the book. So make sure you check them. They are in the back of the book.